Well, welcome back to our course on systems design as we look at Dennis, Wixom, and Roth, their perspective on system analysis and design, primarily focused on an information system, although the principles do have some applicability across to a variety of other complex systems, and I'll continue to try and think about that context as we go through this material. We're now into the fourth section, the final phase where we get into implementation. And for this first lecture, we're going to be, in this section, we're going to be having an overview of what we do when we're moving into implementation. So as the design phase is completed, the system analyst begins to focus on the task associated with building the system, ensuring that it performs as designed and develops documentation for the system. Programmers will carry out the time-consuming and costly task of writing programs while the system analyst prepares plans for a variety of tests that will verify the system performance as expected. Several different types of documentations will also be designed and written during this part of the system development lifecycle. So we're going to focus on three things here. We want to be familiar with the system construction process. We want to explain the different types of tests and when to use them. And finally, we want to describe how to develop the user documentation. As an introduction, when we think of the implementation phase, it begins and foremost on people's minds as the construction of the new system. A major component of the building the system is writing programs. So for information systems, that is definitely going to be a big part. The implementation phase consists of developing and testing the system's software, documentation, and new operating procedures. During this phase, it is also the responsibility of the system analyst to finalize the system documentation and develop the user documentation. So how do we go about managing the programming process? We want to think about the assignment of programmers. We want to coordinate the activities, and we want to be managing the schedule. So we have an interesting thing, the programming paradox, that more is not always the answer. So more is not always better. After the quote, right number of people are assigned to a programming task, you want to be adding more people slowly rather than fast because it can cause more complication of the project. And so keep that in mind. Projects require a large team should be broken into a series of independent smaller parts. So you modularize the code. So we can see this way of how communication goes. If you have two people versus if you have four people, there's two communications between two, but there's 12 when we look at four people. So minimizing the number of programmers is a good strategy when you want to focus on modules of code. You want to match the programming task with the programmer's capabilities. And when the skills are deficient, you want to apply mentoring and training. So in terms of coordination, here's the things that you can be looking at. You can have weekly meetings. The goal would be having them brief. You want to create and follow standards. You want to organize a programmer's work areas. And so you have a development area, a testing area, and production area. So there's a focus that's different for each one. You want to implement change control mechanisms. And so you have a good sense of where and when things are changed. And so a track record. You want to use program logs to monitor the program changes. And many case tools are set up to track the status of programs and to help manage programs as they work. So we're talking about large enterprise type of programming here. You want to be managing the schedule. You want to use the initial time estimates as a baseline. You want to revise time estimates as construction proceeds. You want to fight against scope creep. It's always important to quote monitor the quote minor slippage and keep snipping in the bud as soon as possible. You want to create risk assessment and track changing risk. And finally, fight the temptation to lower the quality to meet the unreasonable schedule demands. What are some of the classical mistakes that you want to avoid? You want to avoid research-oriented development. If you use state-of-the-art technology, it lengthens the planned time. You want to be using low-cost personnel. Or what do we do in that kind of mode? If using a significant number of entry-level personnel, it lengthens the planned time. So we have this dichotomy. If you have experience, it'll go faster, maybe cost more per hour. But if you have lower entry level, it could lengthen the time because there's a learning curve. You want to think about lack of code control. Use source code libraries to keep programmers from changing the same code at the same time. That would be a strategy. And you want to consider if you have inadequate testing. You always want to allocate sufficient time for formal testing. So let's get into more details about testing. So writing programs is fun and it can be a very creative activity. Testing and documentation is not fun. And so this is unfortunately something that's very necessary, both parts, testing and documentation. Testing helps ensure that the system performs as outlined in the specifications. It's dangerous to test early modules without an overall testing plan. It may be difficult to reproduce sequence of events causing an error, and testing must be done systematically and resulting in careful documentation. You want to have test planning. Testing starts with the testers developing a test plan that defines a series of tests that will be conducted. And what we see today, automated test tools enable comprehensive testing of all relevant test conditions. So this is just an illustration of what a test plan template could look like, at least for some aspects. So here are the categories of testing. First of all, stub testing. You test the structure before all modules are written. So it just has a hello statement or returning of a something, but so you get the basic idea of the structure. Next, you get into unit testing. It tests each module, and you want to verify does it perform its function. Integration test is next where you test the integration of modules. Do they work together properly? Finally, we have systems testing, which accepts the to assure that the software works well as part of the overall system. And then the final part of testing is acceptance, where the test is to assure that the system serves the organizational needs or what the customer or user wants. So we'll look at these. So first, stub testing. Not all program modules are likely to be finished at the same time, and so having stubs can be helpful. Programmers usually write stubs for the unfinished modules to enable the modules around them to be tested. A stub displays a simple test message on the screen or returns some hard-coded value. So there's 4 general states of testing: unit test, integration test, system test, and acceptance tests. So we talked about the stubbing, so now we're getting into the other more detailed forms of testing. When do we find errors? And you can see that this is how it usually goes. The unit testing, you do find some. It peaks when you start to do the integration and then starts to ramp down as you get into these higher level forms of testing. For unit tests, they focus on one unit of program or a program module that performs a specific function. The unit testing lists, it's performed after programmers have developed and tested the code and believe it is to be error-free. And there's 2 forms of testing. First, black box testing that focuses on whether the unit meets the required state stated in the specification. And white box testing is you look inside the module at the actual code. For integration test, we have a couple things here. We can be, first, there's the user interface testing. We want to test and see that each interface is functional. We have the use scenario testing. We ensure that each scenario works well. We have data flow testing where we test the process in a step-by-step fashion. And finally, we have the interface testing and ensures that the data transfer between system is working properly. For system test, we have the requirements testing that ensures the integration did not cause any new errors. We have usability testing where we explore how easy and error-free the system is to use. There's security testing. We are sure that the security functions are handled properly. We have performance testing. We assure that the system works under high volume of activity. And finally, we have documentation testing where analysts check the accuracy of the documentation. For our acceptance tests, we have alpha and beta testing. So alpha testing is performed by users to ensure that they accept the system and as frequently repeats earlier tests. Beta testing uses real data, not test data, and actual users monitor with the results for errors or needed improvements. The user sign off following acceptance testing indicates that the system is ready to be placed into production. Well, for developing documentation, documentation provides information to make the system easier to use and repair. For the system documentation, it's intended to help programmers and analysts understand and maintain the system after it's installed. For user documentation, it's intended to help users operate the system. For producing documentation, high quality documentation takes about 3 hours per page or 2 hours per screen. Just to give you some idea, the task should not be left to the end of the project. The time required to develop and test the user documentation should be built into the project plan. And online documentation is predominantly done today. What is the value of online documentation? Searching is simplified. Information can be presented in multiple formats. The new methods of interacting with documentations are possible, say tooltips, animated demos, narrated demos, and it's less costly than paper documentation. So what are the types of user documentation? We can have reference documents. These are designed to be used when the user needs to learn how to perform a specific function. There's procedure manuals, which they describe how to perform business tasks. And finally, there's tutorials that teach people how to use the major components of the system. Okay, for guidelines for crafting documentation topics, you don't want to omit any step because you, quote, assume the user knows how to do that step. Include everything. Use an active voice with direct instructions. Use consistent terms. You want to use simple and friendly language. You want to use parallel grammatic structure. Use steps correctly as actions and use short paragraphs. Okay, well, that's the synopsis of this chapter. Let's just do a review. We identified and described the essential aspects of managing the programming process. We looked at identifying and describing the elements of a test plan. We identified and described the focus and types of the unit test. We looked at the focus and types of the integration test. We looked at the focus and types of system test. We looked at the focus and types of acceptance test. And finally, we looked at the focus and types of user documentation. And for our key terms here, we have alpha and beta testing. Some of you may have familiarity with that. We talked about code stubs. That's something that's beneficial. We talked about use scenario testing and a lot of other things that you can see in this list. So short lecture, but that's the material we have for this. Thank you very much.